Alrighty, so we're going to find the gravitational field at point P and at point Q. So in these problems, more than any others, you really have to mind your P's and Q's. See, I can't hear you laughing. So. All right, I'm going to call this charge, or this mass A. I'm going to call this mass B, just so we can keep things straight. With gravitational fields are toward the mass. So the gravitational field of A at point P is to the left, and the gravitational field due to mass B is to the right. It's toward the masses. So that's relatively simple. Okay, and then remember that gravitational fields are gm over r squared. In fact, this is actually in the data packet, whereas the one for electric field is not in the data packet. So we got to be careful, right? Okay, so for this guy, the gravitational field of G is of A at point P, okay, is 6.67 times 10 to the minus 11th, and that's our G constant, right? And then the mass A is 3.5 times 10 to the 24th, and then we got to divide by the distance squared, so 4.3 E6. That's squared, and this will be to the left. So let's plug that in. 6.67 E minus 11 times 3.5 E24 divided by 4.3 E6 squared. And that is 12.63 to the left. Why is it to the left? Because we're looking at point P, and mass A is to the left of that, and gravitational fields are toward the mass. Okay, and then G is the gravitational field of B at that point P, right? So this is, and then we'll do Q over here, right? Okay, this is going to be G times, this mass is 2.5, E24, right? And then this distance is 6.2, E6, and then don't forget to square it, right? Or you'll get a really big number. All right, so let's see. I'm going to go up there, I'm going to go boop. I'm going to change that to 6.2. Change that to, what is that mass? 2.5. All right, this is 4.34. And this is to the right. Okay, so ultimately adding these up, I'm going to go negative 12.63, because I just make everything to the left negative, plus 4.34. Okay, so I'm going to go opposite of, and I'm actually using the actual number here, so minus, I should be okay though, because I've carried like extra digits, and I just messed that up. Okay, so hold on, opposite of this plus this other guy, and I get negative 8.29, and this is newtons per kilogram, and this would be to the left in parentheses, right? Okay, so yeah, we got that, right? And then for this guy, for Q, at point Q, here, let's change the color. Let's try the red pen land, right? So this, the gravitational field due to B, or Great Britain, is to the left, and the gravitational field due to A is also to the left. It's just toward the charges, right? And now we're all set. We can just add these up, right? So at point Q, colon, right? G of A is equal to 6.67, E minus 11. Oh golly, how far away is A? A is 4.3 plus 6.2 plus 4.8, 15.3. Okay, so it's over 15.3 times 10 to the 6th squared, and then let's see, what is A? A is 3.5 times 10 to the 24th. All right, that will not be a big number. All right, here we go. I've got a number here, so I got to change this to 15.3. So here we go. All right, and then it's 2.5. Is it? No, it's 3.5. 3.5. Okay, here we go. And that is 0.997. And that's newtons per kilogram. And that is left. And then G of B is 6.67. And it's to the left because we're at point Q, and that mass is to our left, and so it'll be toward that mass, right? So minus 11, and then B is 2.5, E 24, and then this distance is simply this one right here, 2.5. Whoops, E, oh yeah, whoops, no, what am I doing? I gotta divide by the distance, good God. I'm having a hard day today. All right, so it's divide by 4.8. Ignore that. 4.8 E6, right? And then square that. Don't forget to square that. So here we go. I've got that number. And that is 4.8. And then our mass is 2.5. And that's 7.237 to the left. And these guys are both to the left, so negative 0.997 plus negative 7.237. So the opposite of this guy minus this guy is negative 8.23. Right, which is, of course, negative means it's to the left. Or however you want to do that. All right, there you go.